yeah, I figured I would just get that out of the way so people could have it if they weren't able to see in real time. I'm just waiting on the thumbs up here from. There we go. Yeah. Okay. So the Twitter is started. They were just a minute late on that, but it seems like you can go to that stage there if you don't want to be in the Discord, which is awesome. I'm really happy that we're breaking through the second veil there. Okay. All right.
Awesome.
Well, we're here with David from Ready, and we're ready for this presentation. You were just up a week or so before, both of you. I feel like I've been tag teamed again, but this time it's not about Huawei necessarily, and we're going to be talking about 33, which has been here for a while, and maybe we should jump into a bit of like a backstory here, David, like how you got involved in Bittensor, because I remember I think the first call we had together was more than a year ago.
It was, yeah, and we'll get into some of that. But yeah, we really came to Bittensor and sort of learned about it in earnest right around the time of the launch of Subnets, back a year and a half ago. And I'll get into some of that. Maybe I'll just quickly jump in the presentation. It's like slide 2. But effectively, our mission here at Ready is to structure all the world's data and make it universally accessible to AI. I do have to do a little hat tip to Cons for really helping us crystallize that specific mission statement. But we really feel like that encapsulates what we're really trying to build here. And so, the scale of structured data and the problem here is pretty massive. 90% of the world's 335 zettabyte of data will be unstructured by 2027. Only a very small 3 to 5% of this is tagged and accessible to AI workloads. And so, kind of to your, initial, what's sort of the background on us joining, we really came at this problem, starting our company as AI model builders. We were really focused on building digital twins initially for creators. Now we've launched AI agents for groups like Common Crawl, continue to do that for creators like Seed Phrase and in the crypto community. And then I know a number of the people on here are probably familiar with the Tau agent that we launched a couple weeks ago. So for us, structured data is the linchpin to highly accurate model outcomes. And the reason why we're really drawn to Bittensor was the structure around the incentive and sort of the validation mechanism. And as we understood sort of what was going on in the annotation and kind of structured data space, we were seeing LLM getting performant enough to do these tasks better than humans. And we also, were really kind of, blown away by how well this problem fit into the Bittensor design. And we'll get into more of the specifics there, but especially having kind of the built-in QA that you get with the validators scoring these LLMs, performing the annotation tasks, we're able to dramatically lower the costs of annotation, democratize that access to enterprises that are far outside of just the Mag 7 and the largest kind of AI shops. So what we now kind of really see happening on the data side is there's a new paradigm around structured data usage, really specific to AI agents, and a lot of that is driven by the MCP standard. So I'm going to kick it off over to Dan here. He's my co-founder and CTO. He's going to talk through some of our vision of where we see structured data headed and where our subnet fits in.
Okay, I think it's useful to start with how our subnet has evolved and why we think Bittensor in general and Subnet 33 in specific are poised at exactly the nexus of what will be the third AI revolution. Subnet 33 began with a mission to create high-quality conversational data sets and tag them with metadata for conversational RAG solutions. And the subnet has been very successful in that area, and Dave will cover some of that later. But since its launch, Subnet 33 has really evolved, though its potential has broadened along with its mission. I want to start talking about data, and then we'll look at some of the new exciting processes that make this data actionable. So we're kind of characterizing the first AI revolution as the dawn of LLMs and transformers that use data. So in what we call single-dimensional data, they trained these LLMs on a vast amount of unstructured data, such as scraped web pages, scientific papers, books, and other things. They did basic cleaning on this types of data, and that is what created really the first, the GPT-2s of the world. In what we're calling the second AI revolution, that's kind of what we're in the middle of right now. And that's kind of the semi-structured data, where we have kind of two-dimensional data that allows RAGs and optimized domain fine-tuned models. So it's basically taking that raw data and adding one level to it. And Subnet 33 is kind of a perfect example of this. So if we look at conversational training data of the past, the ones that were trained in kind of the first generation of AI models, they trained on a lot of long transcription blobs of text. The text wasn't even segregated by speaker. It was just kind of one transcribed long piece of text. And that's what the original LLMs were trained on. And even a lot of the present day LLMs are trained on that sort of data. So Subnet 33 added this second data dimension where the conversational data was not just one long uninterrupted stream. Instead, it had things like speaker identification by line spoken. It had who the speakers were. Then we used the subnet to tag that and add categorization to that. So it added this second dimension to every conversation that allowed for kind of broad sorting and categorization of that data. And so this two-dimensional data is perfect for the current standard, you could say, of high performance, high precision RAG solutions, where an LLM's response is augmented by specific data that's appropriate for the current inference situation. Now, the real, that's exciting enough, I think. But the third revolution, I think, is kind of upon us. This is where what we're calling the n-dimensional augmented data. That's where much more powerful than single pieces of data. This involves qualitative augmentation of each piece of data. So to make that more clear, let's take a look at like what a single web page is. So in the first dimension, the single web page was just crawled, you had basic data cleaning, maybe some identification of the site that page came from. In the second data dimension, we have metadata that's added, tags, categories, basic annotation, maybe for video or image there. So we have that augmentation. But now in this new paradigm, in this n-dimensional data world, we launch into a world where each piece of data is augmented with meaningful synthetic data that's generated specifically for it. So a simple example, a very simple example that's already is just a page content summary. And as we get into this world with LLMs.txt and NLWeb, that is a critical component of this third wave. But we also can see a world where extra dimensions are added around the content associated with that piece of data. So in a simple example, for a web page, you have CSS and JavaScript that's associated with those pages. In the old paradigm, you basically might take that CSS and JavaScript and just shovel it into your training set. But in the new paradigm, you can see where meaningful synthetic data will be created from that associated data. Like, let's take CSS, for example. You know, like, what are the primary and secondary colors of a web page? How do those colors relate to the topic area? Is this a warm, friendly page or a by the books technical page? How big or small is most of the text to understand the target audience? What's the visual ratio between text and images on the page? You can see how all of this information actually needs to be created, but then once it's created, has this profound effect in that data to be organized and used. So if you can imagine how earth-shattering this kind of thing will be, and how, if this n-dimensional data plays out across the entire web, how powerful that might be. Business data could be analyzed across time to include summary trends per company or per industry. Stock analysis could be attached and correlated to industry trends on a granular level. Imagine, just in a simple example, your individual health data. So you already are collecting that through Apple Watch or whatever. Imagine that could search against cutting edge research to create a data picture of the best choices for your individual longevity. So that's all made possible by this n-dimensional data. So some of this work has been done in the past, but it's only been by very large organizations such as Google or Meta with their siloed private data center, and most of their data is optimized for targeted advertising. So we see a much broader impact for that. So if we go to kind of our process vision, so that data in and of itself might not meaningfully change things, because still that data is so large and so broad that it's hard to do anything if you don't have a centralized data center like Google or Meta. And that's kind of where this new standard of MCP shifts the whole paradigm and creates a whole new data landscape. So MCP technology opens the door to everything that SN33 and other subnets are doing. So I'm going to just, for people that might not be completely familiar with MCP, I'm just going to provide a simple explanation. MCP kind of creates a plug-in environment for LLMs. So in a rudimentary sense, if you can think of the way that how printer subsystems allow programs to print to any printer that has an available driver. Photoshop doesn't have to be retooled when a new printer comes to market. That printer adds a driver and all of the existing programs to take advantage of it. So think of MCP as providing the same thing, except for data and processes. So think of all the structured data of any source that an MCP has that can flow right into your LLM, like through something like Claude Desktop or maybe a third-party tool. So let me give you a concrete example, because I think this really shows some of the power of what this could mean. So let's imagine that we're working at a website provider, Squarespace, okay? Like Squarespace. Let's say we want to launch a new website focused on cross-country. You might go to Squarespace, you might select a simple template from the available existing ones. In AI, it might even help you to modify it or write some basic content for you. But that's pretty much it. That's where it ends. Now imagine an n-dimensional data workflow with MCP-enabled plugins. Okay, so you say, I want to start my cross-country skiing website. It automatically searches for that metadata for popular websites and grabs the augmented data. Now, the color scheme for your new website is no longer matched to just the high adrenaline ski or snowboard sites, which most templates focus on. But instead, it goes to other it sees the metadata from other cross-country websites and provides like a color scheme that's like scenic or calm, like other cross-country sites. The augmented data for these websites also indicate that it's an older demographic that you're hitting with cross-country skiing. So articles might be suggested for clothing that's more durable than fashionable. Or maybe the JavaScript indicates that slow transitions for animation is preferred over the hyper video jump cuts that most skiing sites focus on. Text density, let's say the text density is higher because it targets an audience that's more thoughtful in consideration of the sport instead of making a quick pick based on a friend's conversation. So I hope this example has kind of highlighted how you can imagine this synthetic generated third-dimensional data or n-dimensional data really can enable something. This whole example would be possible with a simple MCP plugin source data from Common Crawl that was processed through Subnet 33. So I think this is an exciting vision that we can see for the subnet.
Yeah, and what's really exciting, and just to sort of finish off on the vision piece, today we're excited to announce that we've actually rolled out the second part of our Common Crawl partnership, where we're now doing a Common Crawl data set that's optimized for MCP, that's utilizing Markdown and LLMs.txt, and we're going to be doing that for the entire 20 terabyte crawl. Ultimately, we've started to push out a small percentage of the traffic on Subnet 33 today. So there's now Common Crawl Markdown data that's now kind of expanded. Once again, sort of the data sets that we've been incorporating into the capabilities of the subnet.
So, do you mind if I ask some questions about this, Dave? Or
Yeah, please. Yeah, I think that was a meaty piece.
It's a meaty piece for sure. So, just kind of repeating back to you, like in like a AI V1, we're pre-training on unstructured data, Common Crawl, in all of its craziness. It's just everything, right? Like it doesn't have any refinement of the information alongside it. And as a consequence, it takes a longer time to train. It's harder to search. When you do search it, it provides you unstructured data. It doesn't. You'd have to do the synthesis yourself. You'd have to go, okay, well, I'm going to take an LLM and now summarize the text, and then take that summary and put it into the context window of my model to really get the juice out of it. So you guys are kind of situating yourselves right at that in the center between the LLMs that need access to all the data in the world, delivered to them right away and timely, and all the data in the world, which is unstructured and unsynthesized and unthought about. And you guys are basically positioning yourself in between and saying, well, we can turn that into a perfectly distributed problem, an incentivized problem, which is how can I structure and append metadata, like additional information that an LLM has thought about, the higher thoughts about the unstructured data that makes it actually valuable. So you're turning it into a library and not just a pile of trash.
Yeah, absolutely. And I think we sort of came at, building out the subnet with sort of an eye towards open source and sort of an eye towards commercialization. So, we published our conversational data set with kind of metadata a few months ago. Pretty exciting to report, and we have, in the slides there. But that's the number one conversational data set on all of Hugging, kind of 1,000 conversational data sets there. So that's, obviously been a nice addition to the open source community. We see this Common Crawl kind of Markdown LLMs.txt optimized. We've been working with them. Obviously, this is an area that they're really interested in kind of seeing a next kind of 2.0 version of the crawl. Because when you look at Fine Web, or these are all just cleaned, but really for the purposes of pre-training and not for the purposes of kind of this next gen of MCP.
So the end product here is a database of structured content.
Multiple databases. That's one of the beauty of MCP, that it itself decentralizes this process where you can have an MCP that can look at, oh, you're talking about website design? Go look at this data source that's very specialized towards that. You're talking about skiing? Go look at this data set. That's one of the real powerful aspects that we see of MCP, where you can imagine running your MCP and, oh, you have a conversational problem, it can talk to the Subnet 33 core data set. Oh, you have a problem that's related to your brand, it can talk to another data set in another place or another API. Does that make sense?
Yeah. And you guys are adding this metadata, and this metadata comes, in your subnet, it comes from LLMs that actually read the data and think about what it means and add that interpretation as an LLMs.txt effectively associated with that data. It's a document, it's a web page, it's the HTML associated with the web page, correct?
Exactly. Yeah.
And one of the real distinct and interesting things that we found in our launch of Tau Agent and seed phrase and the types of data and the final need for that data really benefits from thoughtful interpretation, thoughtful prompts that are specific to that data to organize that data for the task. So this really provides an opportunity where you can have the data that matches the task that then the LLM can use for what it needs.
Right. And when an MCP, when your agent, for instance, like a Tau agent, it's called Tau agent.
Tau agent, yeah.
And so it has an MCP that, you read the question and it decides to look at one of these data sources. These data sources have been created by you guys. They're in individual databases behind an endpoint, I'm assuming. Correct me if I'm wrong. It picks one of them and it queries into this database and returns the information, which may be a website or a document with metadata attached. Is that like the flow here?
Yeah, exactly. That exactly is what we do.
And so, when I'm using other LLMs that are web connected, that use like the Google API, right? They have, harkening back to your guys' mission statement, right? It's to organize. Google's statement is organize the world's information and make it universally accessible to all, right? And understandable. I believe. What makes that better than, say, the indexing techniques that they have at Google, like where you ask a query and Google has some fancy token indexing plus AI models that pick out the content and this index and the pages that you should see. Like, what makes this distinct from just using like Serap API?
Exactly. So that's one of the things that's really exciting, and one of the things I just mentioned about how the needs of it are very specific. When you look at what Google does in its search API, it's basically going to that kind of first level plus whatever magic they have working behind the scenes. So they've spidered the whole web and organized it really a lot around like what's the most recent, most current, and they're adding most of their metadata and organization around advertising and stuff like this. One of the things that as we were working with Common Crawl and looking at this, that we really realized, I'm sure that everybody's familiar with this, oh, Google's getting worse and worse, and I can't find anything on Google anymore, and that type of thing. I think that's because Google is optimized for its profit model. It's optimized for what they're trying to do. In this scenario, you can see that this n-dimensional data can really organize around what you're looking for, or the topic areas that do require, just to use a very example with seed phrase, when you go in and do an enabled search for NFT collections on the seed phrase bot, the seed phrase agent, the Google GPT search is not very good because it's like, it doesn't understand, oh, maybe this collection was big 6 months ago, but now has already been labeled a rug pull, or do you know what I mean? So it has lots of conflicting information. We really needed to spend the extra time for both seed phrase agent and Tau agent to make sure that it could answer with the data sources that were accurate and, almost most importantly, understood the data that they were looking at. The type of person that wants to talk to seed phrase is not a general searcher. Does that make sense?
Yes.
Well, and I think another sort of important thing too, and I don't know, there was I thought a great talk by Andre Karpathy at the YC event just recently, where he talked about software 3.0, and talked about sort of the biggest companies in the world, right? Like the Stripes, the Vercells, like they're already optimizing their documents for these formats so that it can, there's such precision required in the execution of the agents that that information needs to be presented, in as actionable of of a format as possible.
Right. This like, you guys are basically adding compute to data, right? Because it's an element of adding intelligence to data.
Yep.
I want to get ahead of myself because I'm going down the tech path here to start asking questions about your validation system and if there's high kurtosis in your incentive landscape. But I'm just not going to go there and let you guys continue with your presentation.
Sounds good. We'll keep going. We get back to a little bit of that. So, So I mean, we've kind of been talking a little bit more about kind of the large scale data sets, we can build and publish, open source. But the opportunity, many companies, the Stripes, the Vercells, right? These are groups that are already doing large structured data projects. That market is already $5 billion today, growing to 17 billion over the next few years. And many of you may know, but the largest player, Scale AI, was just acquired by Meta. Well, not effectively shut down, but basically all of the largest customers of theirs, Google, OpenAI, a number of others, immediately stopped working with Scale. I think this is another really important component of sort of this market where it's really important for people to own and control their data as an enterprise. So I know we've had some of these conversations with other subnets on the stage where there are data privacy concerns that all subnets, need to address when it comes to a decentralized solution. And there's some things that we are going to talk about on the roadmap, in terms of how we're looking to tackle that. But I really strongly that once we overcome those as a community, that enterprise is going to be looking to host their own infrastructure on Bittensor, their own validators to access these commodities, because they need to keep control of their destiny with their data. And we're kind of seeing that, I think, right, kind of in full view with kind of what's happened with Scale here in the last couple of weeks. In terms of the team,
Wait, Dave,
sorry.
if you don't mind, don't
Yeah.
let me interject here. So the going back to the previous slide, the
Yep.
unstructured, the structured data market, Scale AI is in there. Are there players that are solving a problem very similar to what you're describing right now, where like, hey, I want a query for web pages that are about cross-country skiing, and they provide you those pages with LLMs.txt?
That format is definitely newer, and I think we're sort of excited to be pushing that out, already.
At the forefront of that.
But that is definitely kind of the where we're seeing the biggest enterprises going with their, kind of their web and kind of documentation.
I digress.
No worries. So quickly, just on the team, my background, I studied economics at Harvard, studied and kind of wrote my thesis around incentive design in kind of the real estate market back kind of pre there being a thing called crypto. But I've always been really excited about sort of incentives in crypto. Started investing in the space 12 plus years ago. Spent most of my career as an investor, worked at Disney, did M&A and strategy at corporate, worked on the Pixar deal and we acquired that, and then ran investments for the former CEO for about a decade. That's where I met Eitan. We've known each other for a decade plus. He co-founded Applied Semantic, which sold to Google and became Google AdSense, and also co-founded a large mobile gaming company here in LA. And Dan, I guess I'll quickly do his background since I'm running through everyone's, but he's got deep experience on the AI ML side, having worked at Intuit and Demand Media in those arenas. And then on the kind of biz dev sales side, I mean, we are very focused on monetizing, this commodity, have some, stuff to share there a little later on. But Robert, who heads up kind of our biz dev, and Ian, who's our director of sales, come out of some large enterprises like Microsoft and Deloitte and Paradigm, and then the rest of the team on the kind of product and dev side. comes out of some great computer science programs like UCLA and UF, focused on AI. So this is sort of, I think we've already kind of articulated some of this, but really what we're building, for the subnet is this unifying system for categorizing and annotating any data set. So we're tackling this as we sort of go in terms of expanding the types of data that we can run through the subnet, the incentive mechanism and some of the design there. We're looking at re-architecting kind of a 2.0 version of that, so we can truly generalize any sort of data tagging tasks to go through there. But as Dan had mentioned, we started with conversational data. We've layered in social media data, taken a lot of data sets from Subnet 13 and stuff that was kind of pulled off of Twitter and Reddit with Data Universe. We launched our jobs interface, which is where enterprises can do structured data tasks either directly or through our API. And then we've launched Common Crawl today, which will kind of start to replace a lot of the conversational data that's in the kind of the non kind of enterprise or kind of business use of the subnet.
And here is, just for those who aren't familiar with the subnet, we thought we'd just go through a quick summary of high-level description of how it works. So you see at the top, we've got these heterogeneous data sources that are fed to the validators. These can include the ReadyAI endpoint, which has the transcribed or diarized conversation data, the Common Crawl page data, social media posts from Subnet 13, and as well as private enterprise data. So that data comes down into, or is pulled from pulled by the validator. It looks at the whole piece of data or conversation or document and runs a prompt, a set of tags and embeddings that actually act as the ground truth for evaluaating the rest of the data. The data itself, that piece of data, is broken up into windows, which are kind of parts or sub-segments of that data piece, and each window is sent to multiple miners. And the miners run a prompt chain, they annotate that particular window, return the metadata to the validator. The validator then evaluates the returns, scores each against the ground truth, and the miner score then is transformed by an exponential moving average to determine the miner's incentive. And then one other thing the validators do is then they push that data to a remote storage endpoint. In our case, that data is consolidated at a data source and pushed to Hugging Face when the conversation that is being used is retired. As we move into a more MCP-based frontier, it's likely these will be pushed to a variety of different accessible data sources like Postgres PG Vector database for RAG, for instant RAG availability, real-time databases like Firebase, or even another MCP for further processing and annotation.
Yeah, and so go.
Where does the ground truth come from? You said the miner metadata is evaluated against the ground truth. How does that arrive for something like Common Crawl?
So Common Crawl is basically the same process that we use for the normal conversation data. So if you imagine these web pages, we've actually kind of minimum thresholded the page length that it has to be, for example, over 100K to feed into the subnet. So if you can imagine how big 100K is, it's substantial in terms of just raw text. That text is transformed into the markdown. Now, let's just say, just to use pages as a measure, let's say one web page for all of its content then is broken. We generate the semantic neighborhood for the embeddings for that entire page. So let's say those 10 pages. Now let's say that one page, the first page, is sent to the 6 miners, The miners then tag that one page. That 10-page overall semantic neighborhood embedding is the ground truth. Does that make sense?
They're trying to produce an embedding that predicts the full document.
Essentially, yeah. What we call this kind of fractal data mining. The way that the algo works is that one window gets sent out. Now, because that miner is focused on a subset of the overall page, we know that it's going to come back with tags that are appropriate for that page, and we give a score for that. But we also want unique tags, because since it's focused on a small subset of the whole page, it's going to have a lot of specialized data, specialized pronouns, specialized these types of things. So you get credit in the algo for also unique tags so we evaluate it in the broad semantic neighborhood. So we know that you're not just sending back junk tags, but then we're also giving you credit for valid unique tags. Does that make sense?
And the larger space that they're trying to predict into is the embedding or the context tags, as you said. They're tags. They're like it's actual text, or are they embeddings?
They are embeddings. That's how it's actually scored.
Okay.
Cosine distance embeddings.
And so you produce an embedding of the full document. They get a small chunk of it. They produce an embedding of the small chunk that attempts to predict the larger chunk. So they need to basically do a prediction of what is the local semantics of this CSV file. Like what am I looking at here? Give me a description of what this is that describes the full website.
Well, I think what we're doing sort of with the windows is, and this is something that we've kind of optimized the incentive mechanism over kind of early iterations, where it is a combination of the distance and proximity to the whole conversation, but you also need to be providing unique data, unique metadata that is also close to that semantic neighborhood. So it's we are getting a much fuller picture of the data, or a richer picture, because obviously if you do the tags of the entire kind of web page or the entire conversation, you're getting a higher level picture of what's going on in that document.
Interesting. Well, it's an interesting inverted problem, right? So if we're like looking at this conversation, for instance, as example, and we give the miners the last 5 seconds, they would need to produce a section of an embedding tags that say something about the entirety of the conversation, correct?
There would be a component of it, yes, a component of their score that would be that way. And so it's worked extremely well on the conversational data, and as we've sort of expanded to social media data, it's worked well. And so part of where we are going with the subnet, we are going to be re-architecting this incentive mechanism, and we could talk about it a little bit now. It's sort of on the the further slide here, but I have been really closely following the implementation of the kind of GAN architecture by Subnet 1 on Apex, and I think that is a really elegant way to enable a much more diverse set of annotation tasks that we can do while we're still giving the miners the ability to improve their performance. So effectively, how that would work, just so everyone understands. So there would basically be, and I can kind of go to kind of what's next here, but effectively the miner would now be there would be a generator miner that would be generating tags, under time constraints. So time would now be a variable, and we've seen this a lot in our own testing, where doing these precise tags with prompt chaining or chain of thought yields much higher accuracy than it does in sort of one-shot tagging. So the validator would also generate tags. They would have fewer of these constraints because they're building a reference answer. And so then you'd have the discriminator miners who would be telling the difference between the validator's response and the generator miner's response. And so that gives us a much, we think a much broader, much broader canvas for us to generalize this tagging, infrastructure, really kind of infinitely.
It's interesting. Subnet 1 CP'd out to the rest of the community.
Yeah, no, I noticed that was also, what BitMine was kind of leaning into, but yeah, hat tip to those guys because they definitely, I think delivered a really interesting mechanism there. So quickly, I'll kind of hit on, kind of the competitive advantage here, just in terms of how we're positioned for enterprise. We're able to deliver tags at, a tenth of a cent kind of per tag, which is, dramatically lower than these human annotation firms like Scale at 2 to 10 cents. And even kind of doing your own DIY LLM, implementation is going to require you to have some of this QAing process, which is built into the Bittensor design, which is leads to kind of these processing of tags within seconds to minutes, versus kind of needing QA time to push that out to days, if not weeks. And that allows us to democratize this and make it accessible to many enterprises. And we've seen the accuracy of the tags being continuously kind of higher than both GPT and human annotation. So about 51% still higher than kind of GPT tagging.
What's the metric there in accuracy? Like, how do you measure that?
Yeah, so we, on the kind of benchmarking side, I think our view was we really wanted to ultimately kind of create our own eval. I mean, I think a lot of these benchmarks that are out there now are largely gamed, and not necessarily evolving too much. So we've been using our own eval, continuing to kind of test against GPT as well as human labelers. We're doing 3,000 kind of annotation tasks at a time. And I think we're also just from like the quality perspective, we're seeing, kind of our annotation data set now, is the most downloaded on Hugging Face. I think we're seeing kind of the user adoption by the open source, as kind of the quality as well. But that's against kind of our evals.
But what are the evals? Like, how do you measure that? So the labelers produce some tags, you guys produce some tags. What's the ground truth there for accuracy?
So we have a data set that was annotated by human annotator. We actually have several data sets, and one of this comes from one of our enterprise partners. And they then, with those data sets with human annotation, actually went through, did those data sets, and then did the human annotation and evaluation, and came up with numbers like percentage of accurate, accurate flag, in the case of our enterprise customer, flagging social media things. We take that exact data, that kind of, you could say, test data, and also periodically send it through the test net, and then we can evaluate how well that scores against that prime data set. Does that make sense?
It does. Interesting. So you guys are producing best in class? Is this soda labeling?
That's what we think. I mean, we've been tested against a number of enterprises. I'll kind of go into it on the next slide, but we're now, we've been doing, we have 6 active POCs right now with large enterprises. We've got about 2.7 million, in kind of sales in the pipeline. So, feel like we're, in a strong position to really start delivering, meaningful revenue generation in the second half of the year. And one of the things we've been doing to really showcase kind of the quality of the structured data has been around our AI agent deployment. So we've done that with Common Crawl, we've done that with the Tau agent. As far as the Tau agent goes, I just want to talk a little bit about that because we have a fun announcement there. So we've gotten a ton of great feedback from the community. We're going to be rolling out features addressing that over the next couple weeks here. But we also, starting today.
I don't. Oh, sorry, I didn't mean to interrupt. I don't know that people know what Tau agent is.
Yeah, I guess I shouldn't assume that everyone does. But yeah, basically we launched an agent that's right now available on just on Twitter, that is leveraging kind of structured data across social feeds and other kind of APIs around Bittensor. And we will be rolling out a terminal for the agent that will be token gated. So I think one thing we're excited to kind of experiment with a little bit is another alpha sync, where we're able to drive value to the token with some of these agent launches that we're doing. So Tau will be the first one where it will require holding the alpha token to get access to the private terminal, and you'll be able to use it on Twitter, but that would be sort of in a public forum going forward. And starting with this novelty search, we're going to be posting a comprehensive summary of each novelty search with the agent shortly after novelty search ends. And that transcript will now be in the data set and available for kind of questioning on Twitter once that post goes live. So we'll be rolling out some other cool features around that for the community. And then we talked a bit about the open source data sets. So excited with what we've done with the conversational one. We'll be rolling out the Common Crawl one next. And in terms of things that are coming up, our focus is really on expansion of data set types through the subnet. So Common Crawl is a big one. It's right now just a small percentage of the traffic that we're pushing through the subnet. We want to make sure it doesn't kind of break incentives and everything looks good there, but that will become kind of the dominant data outside of the enterprise and jobs interface data that's piping through there, and continuing to push towards more of this n-dimensional data for the agent space. And we talked a bit about some of the upgrades that we're thinking about for incentive mechanisms, and with kind of our vision of decentralized scale AI of Bittensor. Obviously, there's additional modalities that we can get into and would like to get into. I think there's a ton to do sort of with text, especially now with MCP and kind of the agent space. But we have our eye out on subnets.
So that's us.
That's ReadyAI.
David, there was a massive slide here where you had some partnerships. We didn't go into that, or you skipped over it really fast. Can you talk about what these partnerships are?
Yeah, so we have active engagements with 6 different large enterprises. So those are scale AI type engagements, right? Where one of these groups is processing large amounts of social media data for different specific flags, and that was what Dan kind of alluded to in terms of something that we've already sort of shown accuracy levels well in excess of kind of their human annotators who are specifically trained kind of in that domain too, not just sort of a generalizable one. We're working with a large logistics company right now on specific enterprise data that they're looking to create structured data around. So very excited about the progress we've been making on that front. We'll have some more to report there, hopefully, in the near term here.
What's what would that partnership look like? Like, how would they use the subnet?
So the way they would use the subnet is ultimately, so, we have, kind of the jobs interface and API right now, available for enterprises to put data specific to their, specific to their data needs within some of these limited domains of specific kind of tagging around social media tags, tagging around, kind of the best metadata for, that document. Part of why we're focused is, I was talking about with kind of where we're going. I think that the GAN implementation really enables us to generalize that fully and ultimately enable any enterprise who's, who wants to do any structured data task around text to utilize our API, decide, what that task should be. And ultimately the validator, would be kind of serving up that enterprise's data to the miners.
Yeah, so essentially what we have right now that we're working with these enterprises with is we created a private API that allows them to push their data through the jobs interface, which just I'll briefly describe since we didn't cover it in this. The jobs interface, what you can do is you can add a Hugging Face data set and it will push it through the subnet and do the tagging or social media sentiment analysis or whatever. So that was our kind of our first proof of concept in a general way that the public could see. And so then as we've been working with these enterprises, we've created a private API that then can push directly to a validator that data, sends it out to the miners, data comes back, and then it uploads that information back to their private enterprise data sources. So we've been building all the integrations for, OneDrive and iCloud and all of these things where the interface can actually push and pull. So once they push in the permissions key that they want for their data source, then they can have it run the jobs through the subnet, get the data back. And it's a really interesting thing because what we've been doing is we're very open about how that data, that enterprise data, will be going through the subnet, or we offer kind of a kind of set of solutions, or we could push it privately to our own data stack, or we could co-locate a self-hosted, because we had that request from one of our potential customers of self-hosting their own LLMs. So it's really amazing because the amount, like the common way that people aren't really very privacy conscious in the way that they were a few years ago. When we provide enterprises with these different plans with different costs, most of the enterprises are like, well, we're willing to go for the less cost, less privacy option, but we try and provide all of those.
Well, and obviously sort of the privacy preserving piece, I think, is something that, a number of us on the subnet side are trying to, figure out the best approach. There's an aspect too of just like the scale AI type model where if you're having annotations done on your data, that's going out to individuals all over the globe, where you're not necessarily putting, the most private data through it. So we've found that social media data, and bringing insights to that data, has been, one of the more fruitful categories because it's already out in the public. But I think that is kind of an important like bridge for us to all cross, like where we're, we're present Bittensor in a way that's kind of fully private and understandable to, to get all of the business on top of Bittensor.
How is the interaction with Common Crawl working? So Common Crawl is producing terabytes of data per month, correct?
Correct. Yeah.
Yep.
And you guys are labeling a good portion of that?
Well, yeah, what we're doing is building an entire data set around that. I mean, we won't get to 20 terabytes, instantly, but yeah, we want to deliver a full Common Crawl, like a fine web, kind of version of Common Crawl, which is, kind of the main one that's used, for open source and pre-training, but for kind of markdown LLM.txt.
So,
And so that'll be the vast majority of the data, right? That's piping through the subnet. I mean, we're still primarily using, synthetic data, versus the organic data, from enterprise, and hopefully that starts to move more and more to the enterprise side.
and so Common Crawl, you guys are chunking a whole bunch of that, and you're turning it into your own data set, and that's on Hugging Face?
Well, we started putting the data through the subnet today. That was what so we are starting to process the crawl today.
Oh, okay. That's exciting. That's exciting. So
Yeah, that was
Very.
Yeah, that was sorry if I buried the lead there, but yeah, so we just pushed that update to the subnet today.
and
So
so
that's what they see as we see this this LLMs.txt being one of those items that brings us into that, n that new generation of data organization where Common Crawl becomes more and more useful as we generate this extra metadata that makes every crawl that they do more valuable.
right, right. And so the end result here could be like the best pre-training data set ever.
Absolutely.
Like instead of training on Common Crawl, you train on this like enhanced Common Crawl, where it has all of this like the extra juice added to it.
Yeah, and to your
And
point before, presumably Google and Meta and stuff are already doing this internally and keeping the data private, right?
right,
Something akin to this. But our whole point of Common Crawl to add value to what is already public. So I think it'll just be a windfall for the whole community and the world in a larger scope.
you guys you're producing these data sets, but they're not necessarily like immediately searchable like the Google API provides. Are you guys taking steps to make these data sets available to, like let's say that I want to replace the Google API in my agent. I don't want to search just on Google. I want to use a custom structured data search to improve my performance on some task. How
Okay,
can you hit that vertical?
So that's what's really exciting about the MCP technology. Okay, so right now, let's say Common Crawl itself. Common Crawl has an ability through Athena to be able, through the AWS Athena thing that they have, to do a broad search against one crawl. So you can go and find the page for a particular URL through that index. And you can get what data set, what Common Crawl file it's in, what the offset to that actual data in the file is. And that's what we're in fact using for the subnet. So we're grabbing huge swaths of you. The validator then can go out and grab that particular page out of the broader Common Crawl data. So now imagine in a scenario where an MCP can be very specific to what you're trying to do. So instead of a generalized thing, to go back to the skiing example, you could imagine a thing where what you did is create an index for all of the skiing documents in Common Crawl, right? That Common Crawl data exists essentially out there thanks to Amazon's, contributing the free bandwidth and stuff. That all that data sits out there on S3 for free access. So imagine you generate a ski index that the MCP can talk to, right? So one MCP can talk to the ski index, and if you've used MCP before, the LLM itself selects what the best source to find what particular data is. So it can find that the MCP for skiing. It can go out and say, oh, okay, that index is on Hugging Face or in Firebase here or in your database here. Search that, grab the data, pull it back, and inject it into your LLM conversation. So there no longer has to be just one gigantic database like Google has. There can be all of these, large, medium, and small data sets. Does that make sense?
Yes, it does make sense. So you guys are positioning yourself for that future, really.
That's right. And that's where it's so exciting, because if we, especially working with Common Crawl themselves, if we can make all of that data as kind of an adjunct, an extra thing to what Common Crawl already supplies, then people will all build on top of that. And then we've got this really phenomenal new world.
Right. So Common Crawl is all social media, it's all web pages. Like what exactly is Common Crawl? I should know this,
Yeah,
but
I mean,
I don't.
Yeah, I mean it's largely all web, right? I mean, there's some social?
One of the things, there's two aspects of it that as we got into this that we found interesting. First of all, one aspect of, because it is Common Crawl, there's a lot of not safe for work content there. So we have to figure out exactly how, what the boundaries are that we want to put on as far as the subnet is concerned. But there are aspects of it. It is a crawl of the entire, there's two interesting aspects of this, not to go too far off the rails, but the first interesting aspect of it is because of the AI kind of invasion of crawl, a lot of the bigger companies, the CNNs, the Fox Newses of the world, have added Common Crawl to their robots TXT. So in current data sets, that is empty window there. That is missing from the Common Crawl picture. Okay. The interesting part about that is, as we move into this world where a lot of people are worried about AI slop, the Common Crawl is a snapshot of the web at any one time that dates back, 20 years, 15 years. So that allows even the data sets that we're creating to have a window into the kind of pre-slop era, which is also another interesting aspect of kind of the time machine aspect of Common Crawl, and some advantages I think are definitely there for that data.
So this beautiful product for the MCP world for agents is a single MCP interface, which is ready, like ReadyAI, like ready data MCP interface, or is it a whole plethora of just different like structured
I think it's a whole plethora. We're trying to create kind of a reference platform MCP for how you could use the data coming out of Subnet 33. And then we intend to open source that. So then the idea would be then whatever type of data or whatever type of thing you're focused on. One of the things from one of the people that we're talking to, the enterprise clients, they want to focus on business data, which is specifically in this special type of XML format that's publicly available. So we're building some special processes to take that financial data, which LLMs notoriously have been not good at interpreting, and we're building specialty prompt chains and agent processors that can process that data and then generate data that MCP that's specialized to that business data can understand, interpret, and package for the LLM so they can use it effectively. Does that make sense? So
what's an example of that data? What's an example of data what's an example of data like that?
We want to cover that? I always forget, it's XBRLI. I've got the the data format for the profit loss statements, the SEC, all those statements that we're processing.
Yeah, like
What
all
you're
the
what you're
financial.
saying is basically, so like not only do you want to tag data, not only do you want to tag and summarize, you want to tag, summarize, format, extract, and there's like a whole like spectrum of different ways that you can structure the data to make it queryable and easy to ingest by LLMs. It's not just, one type. Is that correct?
Exactly. And I think like, I mean, for me at least, like it kind of crystallizes most with kind of the agentic web, where like the metadata and formatting, the reason why the LLMs.txt is so critical for, Stripe's API documentation is that it has to be precise. They have to be able to get at the specific call, the specific information that they need. And, this effectively eliminates hallucinations, or, kind of misses by the LLM.
Yeah, it is XBRL. It's extensible business reporting language. And there's tons of financial documents that they have that are stored in this format. So we're going to consume those and generate that kind of qualitative metadata off of that can then be used effectively by an LLM.
Why not pair what you guys are doing with the indexing and serving side of this problem? So you're producing all the structured data, but it's just sitting in a Hugging Face database. Is that really the format that you needed?
Well, the thing about the nice thing about the Hugging Face data, there's a few nice reasons for the Hugging Face data. And so the short answer to your question is maybe not. We're trying to figure that out, like where the best place for this data to locate. We want to try and steer away from something monolithic, right? But
Why?
one of the nice
Why do you want to stay? Why do you want to stay away from something that's monolithic?
Oh, because then someone controls and has to take on the costs of that monolithic
Okay.
querying data set, whatever.
But you could hypothetically shard it across your miners even.
Well, we definitely could. I mean, I think, to again kind of hit on the point that today was the first day we've started to, we sort of crossed the bridge of being able to, now include, the web scale sort of data, the common crawl data, and start processing that in kind of the format that we want for, for this agentic web. I mean, I think you're bringing up a good thing for us to sort of think a little bit more about, because yes, this data is extremely valuable and useful to this agentic future. And I don't know that we've taken that next step in the thinking of like where that could go.
The ultimate search MCP that has all of the latest data in the world perfectly structured to return to the model and give them the best view on what's going on. Sounds like, like that's kind of, you're doing this really hard problem of structuring all the data so that it can be accessed by AIs, right? And it feels like you guys want that delivery aspect as well, or maybe there's another subnet Bittensor that can do that for you. But Hugging Face is not really a good delivery tool, right? It's not fast.
We actually just used right now we're using Hugging Face for basically your open source publishing, right?
Right.
So for that need, it's perfect for that. So we don't know in the end exactly where that will be stored. If you look at what Common Call is using, as I mentioned before, they're using a combination of S3 plus an index that can be run through Athena, right? So maybe that'll end up being the thing. As Dave said, we're not that far down the road at this point.
Well, and maybe it starts with, say, making a subnet interconnect here, where you go to 22. You're 33, they're 22. It seems like there should be a connection somehow. And they do look up on a variety of different sources from Twitter, from Wikipedia, a variety across the board. and Cosmic could probably be really interesting to work with you guys because he could just connect that into their structure, which is like a go pull from a ReadyAI database, and then you can leave the structuring and the indexing and the retrieval aspect to a subnet that actually focuses on that problem, which is here it's all structured for you. But now go and retrieve it in an intelligent way.
Definitely.
Yeah, it's interesting.
Unite the clans. I love that, Keith. Keith, you're up on stage, and I'm doing all the hard work here. The host is supposed to be participating in throwing out knives and hard questions.
Yeah, the ideas have gotten big here in the last couple of minutes. David, what kind of like throughput do you guys have? You mentioned you've got 3,000 tasks at a time. What does a task like encompass? How long does it take to do one? What kind of, I was looking at the Common Crawl website, and they're generating like 430 terabytes every month. So they do like basically a monthly crawl during the middle of the month of the web, and then that out. It looks like what is the feasibility of putting that kind of throughput into like a single subnet?
Yeah, so what we're going to do is sort of bite it off in different, kind of segments. We want to go after some valuable sort of categories within the crawl. We're still sort of doing a little bit of the, the calculation of like, how quickly, how much can we sort of process through there. But we can definitely generate, some very significant, like, full category, industries, think business, finance, some of these larger, more valuable ones. We'll probably put adult a little bit more towards the back end.
Right. And additionally, that they are literally crawling the web. So that huge data load may seem like it's just impossible to process, but as we've been going through the Common Crawl, we even have, before it gets pushed into the subnet, we have a bunch of guardrails. There's, a bunch of pages that are just like 404 pages. There's a lot of pages that have duplicate headers, footers, menu. We're trying to take some of that out. So I think the data set is not as daunting as 400 terabytes a month indicates.
Right. And you mentioned also, I saw it on a slide, but I think you just gave it kind of a one-liner. You're introducing a timing aspect to these tasks and competitions now that previously had been like a fixed time on the subnet, or how does it work today, and how will it work?
Yeah, exactly. So time, really isn't a component of the score. They just need to do it within, sort of the allotted time. But what is really interesting about the kind of that GAN architecture is that you can now have a validator that is unbound by time constraints. So they can use chain of thought. They can do these as broken out tasks for the LLM to tackle, which we've seen in extensive testing, just really heightens the accuracy of what you can do. So now the miners will be able to, they'll be required to sort of compete on a time constraint. So they will have to get better and better at putting less and less, prompt chains together to generate a result of the same quality.
So it's as fast as the validators can pump out the tasks. Is that's the limit?
Yeah, absolutely. One of the things that you might have noticed in the slide where we were talking about the privacy aspects of it, we feel that the subnet can take a much greater load if we optimize the protocol between validators and miners. And we can help a lot to reduce kind of the errors and whatever else. So that's one of the things that we're moving towards, is re-architecting the protocol for communication. We're kind of looking at chutes for what they did to talk between the validators and miners, so that we can push a much greater volume through the subnet, so that we can accommodate some of these Common Crawl size of data. Does that make sense?
Yeah, and the way you've architected this, it sounds like validators themselves could also utilize this bandwidth independent of whatever you're doing with Common Crawl, or the partnerships that you guys have created.
Absolutely.
Right. Beautiful. And I guess the other question I have is, how do you guys decide, like, what is going to be the process for determining how you chunk up the web into the subnet and start creating value through open sourcing these data sets? Is that something you guys just have sort of a list, or is it by like page visits or rankings of certain topics? How does that work internally?
I think that's one of the things that is really compelling about some of the stuff that we're doing right now is the subnet, Bittensor itself and the subnet specifically allow you to really have a broad variability of how you address that data. I was mentioning before how you would address XBRL data is much different than how you would address, say, a blog site, right? So one of the things that's really interesting to us is as we're pushing Common Crawl through the subnet, what we're looking to do is kind of gain a data picture of what the Common Crawl data and the broader web looks like. So we're looking to then basically customize and figure out exactly where whatever data that we generate, the qualitative data that we generate, would have the most impact and be the most valuable for MCP. So it's kind of like we have a bunch of things that we've written down that we all are, everybody's excited about a different aspect of where we can go with this. But we're also going to have try and let the data somewhat inform us as to where is the best place to build, where is the most bang for our buck when we do that.
Right. I got another question too. You guys launched the one-click miner back in March or April. How was that kind of received and utilized by the mining community? Is that something people are using? Can you tell if that kind of picked up steam, or how's that going?
Yeah, I mean, we've launched a few things kind of we call it the miner optimal kit, where we really wanted to enable it to be as seamless as possible for new miners to to come online and start mining on the subnet. Want to take away all of the any of the frustrating parts and just have them focus on the actual hard work of optimizing their models for this task. I think have you checked recently, but we've had some pretty significant download numbers of the one-click miner stuff.
The Docker. We really made the when we did the Docker images and published it to Docker Hub, we really made it kind of multitask. So you could launch a validator with it. You could launch a miner with it. You could use it as simply a good, quick way of getting BTCLI online and addressing your own wallet. And we externalized a bunch of things so you could keep your private data store and that type of thing. So while we have a lot of downloads of the image, it's hard to tell. I don't have any hard data on where it's actually being used.
Yeah, it looks like we've got 274 have downloaded it in the last month.
And what's the miner sort of community like for 33? Do you guys end up fielding a lot of questions on the Discord? Do you have miners reaching out individually? I'm looking at the registration statistics, and it looks like you're averaging roughly maybe 20 new UIDs per day or so.
Yeah, no, we definitely have a number of like newcomers coming to the subnet. We know some of the top teams on the subnet who have been with us for a while, but it's been continuously competitive.
And what have you seen happen on the mining side since you guys have done maybe a 3x or so price wise as far as the last 3 months are concerned? Have you seen the competition heat up? The performance has been better, the output better. How has the price change kind of impacted how the subnet runs?
Yeah, I think we've definitely seen, kind of, to your point, with I think the combination of the one-click stuff and also price, a bit of, kind of increase. I mean, I guess that price increase probably has been over a couple months. The last month has maybe been more, kind of, with some of subnet prices, which we don't have to get into. Maybe it hasn't been as up, but Yeah, I think we've continued to see, competitive activity there, and really high quality in terms of the outputs. We are introducing like a very new thing into the subnet as of today. And that's going to become the majority of the tasks. Yeah, there can be a little bit of a changing of a guard here, with some of what we're rolling out.
Yeah, it's interesting because your emissions, I just kind of wonder like how the quality of the subnet or maybe the throughput is changed by the community support, as you guys have kind of crept towards 2% emissions, because that's quite a big difference from, the first month or two we were live.
Yeah, I mean,
It's
I think we
interesting.
were probably closer, before detail. I think we're sort of in a similar position to kind of like, maybe pre-detail now. But yeah, there was, there have been some, um, yeah, some ups and downs.
Cool.
On that note, David, kind of a change of topic, like, um, what have you noticed about the way in which you guys are running your subnet post detail? Like you've come back to about a 2% emission, Keith said, which was where you were roughly before. But like, what has the effect been on your guys' business?
Um, in terms of how we operate the business, I mean, I don't think there's been much of an impact in terms of how we're thinking about, most aspects of it. I'd say like the two aspects that, we sort of knew even leading up to detail, right, that would be a forcing function of it is the revenue generation, kind of focus. So that was why we, launched our jobs interface, our API. Initially we were very focused on kind of conversational data sets and, kind of generating, kind of open source. And so, yeah, I think we've definitely oriented more towards, kind of enterprise sales and driving revenue to the subnet. And then the second thing I think as well is just like, more, much more active in terms of how we think about, marketing and awareness of what we're doing. It's I think it's clear that it's very important for, people to understand what you're doing as a subnet owner.
And we've always tried to be miner focused, but really the efforts that we've put through for the last couple months on the miner optimization toolkit, I think that was a really important thing. And one of those things that with the launch of detail, we really saw that the more we can really cater to that community, to get the miners on our side, to make sure that they have what they need. I think that's a really important. I don't know that it's a short-term impact of detail, but we feel it's going to be a long-term impact of detail. If you have miners, if you have validators that are really invested in your subnet and really rooting on what you're trying to do and the mission that you're trying to accomplish, I think that will have a really dramatic long-term value for each individual subnet.
I think that like post detail, one of the things that I've been telling teams is that if you can retain your miners, they become part of your team. And like before in the root network, that they don't. There's nothing really tying them to the project. So have you guys noticed or seen that behavior in your community, that they're the people you're working with are then more aligned over time with working with you, and that you've actually got some more feedback from them, and they've helped you squash bugs and actually take your product to market?
Yeah, I mean, we've always had I think a pretty active and like vocal group. Definitely more aligned. I agree with you that kind of more aligned now. I think it's important to to kind of foster those relationships. We know the biggest groups who are mining, and we're always asking for feedback from them, especially as we're thinking about rolling out new stuff on the subnet. Yeah, so I definitely agree.
It takes time, and I hope that people look to play a long game. It like took us a long time to build our community. Um, but like in a year in, like I think that's a really good checkpoint. You'll see who's there, like who was there, who left. But I think that you're probably already beginning to like really notice the amazing people in your channel that understand the mission and that can work with you for the long haul to really at the end it's like maintain this network alongside you in the same way that we started this out ourselves lonely, but now we have people like Keith here, right, who's more than just a holder of Tao, but actually like a political, a cultural, and a spiritual leader. So great to have him on stage today, and as well yourself, David. What a pleasure for this presentation. Thank you so much, guys. This was a great deep dive into what you guys are doing, and really exciting stuff. Like these new partnerships and pushing towards revenue and working with Common Crawl. That's gonna be a major like moment for us to hit the Common Crawl and really add value to the greater open source AI industry. I think from what you guys are doing. Yeah, so should we leave it there? Fantastic.
Yeah, this has been awesome. Yeah, thank you, Jake. Thanks, Keith, as always. You are the spiritual leader for sure. And I love that Caro, he always wants to get he said ReadyAI on 3. Well, we can leave it there. Thank you, guys, and yeah, appreciate it.
Bye, guys. Have a good night.